So I have to warn you that my talk will be a bit different. It will be more technical than the previous ones. So I'm Daniel Torok. I'm a senior engineer at Prezi.com. That's me on holiday. If you don't know too much about Prezi is a presentation software what I'm using right now that helps people to visualize their thoughts and share it with others a bit more efficient way. And just some information about the size of the company, that we have more than 50 million registered users. The company has more than 200 employees. And just to show the size of the backend infrastructure of Prezi, we have more than 800 virtual EC2 machines running on the Amazon cloud. So I was one of the engineers in the team which worked on creating a new infrastructure for the Prezi backend based on the microservices approach. And if I would like to summarize my talk in one sentence, it would be something like, having monolithic application, we decided to start building a microservice-based architecture, and finally, we split our big app to several small services. The end. So the funny thing about this, even if it's completely true for us, is that it generates more questions than how many it answers. Questions like, why did we decide? What was the problem? Or why did we choose microservices at all? What is a service? How do we define that? And from the technical view, how do we do a split? It's so easy to say that we split it up. How did we do it? And the most interesting question, how long did it take? So let's take the bitter pill and talk about the painful question at first. So what do we have to do? At first, so we have one application, right? The large rectangle. And what you have to do to create a small application, choose some features, but we want to move from the huge application to the new one, so we create a small square. And what we have to do just to make sure that somehow the huge rectangle will talk to the small square. And finally, we move it to the Amazon cloud. So that's it. This is we planned with time, and what we did, we thought that we will finish this project in about 3 months with 5 engineers. And we ended up eventually in 10 months. So this is what I'd like to talk about now, what kind of decisions we made, and I will try to explain how we decided and why it takes so much time, and I will try to armor you with some knowledge about these things in case if you happen to do something very similar to this. So let's talk about, may I take the microphone? Yeah, sure. Okay, thank you. So let's talk about about why we chose it. So the history of Prezi is very similar to the history of any other startup. Like we were working on the client side, and there was the so-called backend engineer in the company who began to work on the application on the server side. He was a Python expert, so he chose Python and Django for that, and he started to write this one application, what we can call Prezi.com, because this was everything what you could find in Prezi.com. And this is a completely, it's an absolutely perfect approach, because a company with 100 or with 1,000 users doesn't have to think about, or mustn't think about, how they will scale up to 50 million users. So it's absolutely fine, so as far as your business is small enough and you have only a few developers. But as the company grew and the application became bigger and bigger, we realized that the business is not that small enough, not that small anymore. So we realized that having this big application is not good anymore for neither availability, because we saw that there are few a small bug or a failed deploy can pull down the whole Prezi.com application, and it wasn't good for scalability as well, because we were running this application on physical hardware, and we realized that it's not that easy to scale up physical hardware, so we wanted to move it to the Amazon cloud to run them on virtual machines. And it wasn't good for the developers as well, because we had more and more developers, and we had one huge application with 100 contributors, more than 100 contributors, with different skill set, with different experience, different naming conventions. So inevitably this application began to become messier and messier. And it wasn't good for So it wasn't good for the deployment cycle and the development cycle because the tests were very long and everyone was blaming this one application. It is very hard to work with it and stuff like that. So we realized that we have to change something. But the question why we chose microservices. So is this the only way to cope with this? I think not. So you can say that you handle this big application and you can introduce very strict rules and you can say that you introduce rules for naming conventions, to how to write code, what technology to use, how to write a test, what kind of CI system to use in the background, and you can have these strict rules everywhere. For this you have to build a huge standard technology stack that everyone has to use, and you will have to make sure that the new candidates always know about the rules, the old candidates follow the rules that you set up. So basically what you have to do is to change the culture, which won't be a typical startup culture anymore. On the other hand, you can change the technology and you can say that you get rid of this monster and you start to create a colorful stack where every team is the owner of their own service and they own their own technology, they choose their technology and they are responsible for that. So while having a huge application, it's very hard to really make people feel ownership for that one huge monster. In this case, if the teams has their own services or even one individual developer has his own service, that they will feel much more responsibility for that. But you have to make sure that you take into account that you will introduce a lot of unexpected problems with this. You introduce a new technology, you will have new kind of problems. So microservices approach is good for a rapidly growing company, for the technical and the organizational problems, but this includes a lot of other kind of problems. So what is a service? This may be a trivial question, but it wasn't that trivial for us in the first place. So what we wanted to do at first, so this is what we had, the one application with one database. And we wanted to do just to create a different service with a different database with completely different approach. So what we wanted to create two services what are not knowing about each other. So just only the client knows where to go. But if it's not that easy in practice, so if you take a concrete example, like if you say that the service on the right side is a present metadata service which contains the title of the presentation and contains who has access to that presentation, for example, and the other side there is the Prezi XML service which stores the XML with a completely different technology in the background. And if I want to show the presentation to the user, I go to the Prezi metadata service, get the metadata, and want to download the XML. But this service has to know about if this user has access to the presentation, right? So if it has to authorize the request, what it cannot right now because it doesn't have the information. So what we did that we created So we changed the client to go to the present metadata at first, get some token. With that token, go to the presentation method, the XML service, and then this service to the request and to the token, checked if they match, and if they match, then gave the presentation back. So for that, we had to change the metadata service, the storage service, and even the client, which was pretty complicated. It was hard to debug. So we realized that we can try to avoid connection between services, but there is connection between the services. And instead of trying to make a channel from the client and communicate between the services through the client, we have to solve how the services communicate to each other. So this is how this was our approach. And at first, what we wanted to do is to separate the user service, the user data, and the user-related features from this huge Prezi.com application to a separate application. So how did we do this? So we needed 3 steps for that, shown by the 3 arrows. At first, this is what we had originally, right? And at first, what we did, we created a new service in the same data center, on the very same server. So the servers were running 2 services in different ports, and both the services were using the same database. But we are talking about the user data. You can imagine how many times a web application refers to the user object. a lot of times. So the original Prezi.com application was also using the same tables, the same data. But it was fine as the first step. But the next step what we had to do is to make sure that the new application will, the old application will use the new service for getting user data. And as a last step, when we saw that the old application is not using the user data anymore, just using the new service, we could literally split up the database and move the database with the new service to the Amazon cloud. So this was the first step what we wanted to do, and we planned it to finish in 1 month with 5 or 6 engineers. And what we basically did, that we fired up a new Django application, we copied a lot of code to the new application, we made the test run there, and then we had to always decide what kind of code we move to the new service and what kind of code we keep there, which wasn't that easy, because to be able to decide it very strictly, you have to have a very strong opinion about the identity of this service. So at first we had, during this process, we had to find the real identity of this new service, what it will do, what kind of data it will own. And there were a few things that helped us in this. At first, to decide if this will be an HTML only, the API only service, or it will generate an HTML as well. So it's interesting because this helped a lot of time to decide if, for example, this service will show the login page or not. And if it shows the login page, then you introduce a lot of new problems like design. You will have to make sure that people, if you have a new brand, then people will be able to change the design. The other thing was to think about the data. So at first we decided that these are the 3 tables what we will move with the new service to the Amazon cloud. And I remember sitting there and checking all the functions, if this is something I can implement with this set of data or not. And if I couldn't implement, I always had to reevaluate the identity of this service. So to talk about if this is really the service I want to implement, or should I change the identity and should I include this new function. But always knowing that what kind of data I want to move helped a lot. And the authorization was an interesting topic because we talked about a lot of this. If I have a presentation and I have a list of users having access to that presentation, where does this list belong to? Does it belong to the presentation, or does it belong to the user? So it's a kind of land of nobody. We were thinking about creating a separate service, which service owning the authorization data. But eventually we decided to move the authorization data always together with the entity, the presentation in this case, because this gives a much more distributed solution at the end of the day. So this is how we created the new service. We have the service running on the servers using the same database. So now we could start working on separating the tables, so changing the original application to use this new service. This is what we planned for 2 months, and there were a bunch of expectations we had to meet. Expectations like availability. We are talking about the Prezi.com application with 40 or 50 million registered users, and the authorization data, user data. So basically one of the most critical parts of the system. We had to make sure that we don't mess things up very painfully. When we did pioneer work, which doesn't only mean that we were the first ones in the company working something like on something like this, but it also meant that we had a vision for the future, what we want to reach in the future. And every time we met a new problem, we always had to re-evaluate this vision. If this is still the vision what we want to reach in the future, and in the same time we had to fix the problem itself. And we always had to take into account that this is a project what we want to finish sometime in the future. That even if we always think about the long-term vision, how it would work in the future in 2 years from now, we always have to fix the problems today, and we always have to balance between fixing something today and make sure that it will work even tomorrow. And as a last step, we had to do it with continuous integration. So it was no chance to do this huge migration in a separate branch and eventually after 2 or 3 months of work, merging everything back, deploying to production and hoping that it will work, because it wouldn't, obviously. So we had to find a way how we can commit, merge and deploy everything basically line by line. And let me show you three interesting things where we had to keep these expectations into our minds. So at first the routing code, how did we expect that this will work in the future? Like, we knew that there will be a line where we get the user from the Django, through the Django and from the database. And we knew that we will have to change this to something else. And how it will work in the future when we are already done with this would be something like this. It will go to the other service, do this RPC call, and give back the data. And give a local representation of that remote object to me. And the code will work. But as we wanted to do it with continuous integration, and we wanted to start writing everything in the original code and refactoring, doing a lot of refactoring, and at the same time make sure that we won't break everything, we also had to have a separate behavior of this routing logic, which did just a Django ORM call. Or we knew that we were doing pioneer work. We knew that we will introduce network communication between services which may fail in the future, so we had to introduce some fallback logic in case of a failing RPC request. Or we had to deal with tests. We had a lot of tests already written, and we had to build a new test database for this remote kind of communication. And because we wanted to do this with CI, and we wanted to keep the test green even if only the half of the system is rewritten to this new format, we had to create a special other kind of test backend which used the Django memory backend in the background. So, and this is even more complicated than this. And this shows how a very simple idea became more and more complicated. And I remember sitting in the office and trying to refactor this several times, and it became always a bit better, but I always had to realize that this is a complex problem, and I always try to refactor to give the opportunity to others to really understand how this stuff works. But this is why it became so complicated. And if you talk about this routing, so this is how we rewrote these 70,000 lines of code. Is that we had this original code, we created this remote abstract layer which contained this freaking logic what I showed you before, and we had this different kind of backends, like doing the RPC call, ORM call, and stuff like that. And what we basically did, then we had lines like this, user.objects.get with the primary key 1, and we changed this to this remote user factory get, so there was this remote user entity we introduced here, this abstract entity. Or for example, if I get a user by a username, then we had a function for that. And what we basically did, we went through all the code and changed this Django ORM call to a call through this abstract layer. So why it was important to introduce this layer was to be able to start rewriting the whole application and the whole code without having a very strong and very robust network system in the background. So we could do these two things parallel, and we could merge and deploy and push production everything what we wrote without fearing of breaking everything. And the third thing is a very interesting thing. This is the database references. So let's think about that. We have a presentation object and we have comments on presentation. So the comments belong to the presentation. So they have a presentation ID. So they have in the Django ORM we have a reference for that. And if we have some settings, for example, some language object, and the presentations have some settings ID to this entity. And we also have users, and the presentations belong to a user, so the presentation has a user ID, an owner ID. And if you use Django ORM, then you can write something like command.presentation.owner.email, right? And now let's imagine that we have already moved the presentation and the user object to two different services. So from this point on, we cannot talk about foreign keys. The data is not there, so we cannot talk about database foreign keys. We cannot even talk about Django foreign keys, because Django cannot resolve this. Like I have a command Django object, and I say presentation, it will do some magical RPC call to the other service and get the object back, which will have an owner field that will download a different kind of object from different service. And at this point we had a lot of code using this expression because we were using Django before. So and we were thinking about if this is something that we would like to support in the future, so should we work on this to support this kind of connection between remote objects or not. And we decided not to support this. And this is an important thing, because at first it's a very complex thing. So if you want to have a system where you support all this kind of connection between the objects, like having a presentation and get all the comments for that presentation and make sure that the comments will magically come from the other service, is a very complicated thing. And we just introduced microservices, which is also a complicated thing. We just introduced a lot of new kind of problems the developers will have to deal with. And we decided to keep the code as simple as we can. So we decided not to support this in the long term. And there's the other reason, that these are expensive calls. Doing a MySQL call in a local data center is not that expensive. But as soon as we move this to the different data center, to the completely different part of the country, for example, then these calls will be very expensive. And it's very important for the developers to be aware of the cost of their calls, to make sure that they will know that if I write command.presentation, that it will do a remote call in the background. It won't happen immediately. But on the other hand, we had to make sure that we will finish this project. We had a lot of expressions like this. So eventually we created the system where we support this expression. We introduced a lot of magic, one of the darkest magic of Python called meta classes. And we decided to do it in this service and keep it secret, not even admit that we have done that. And keep it only in this service, because we wanted to finish this task without any cost. But in the same time, we had to think about the future to make sure that other developers will not use it and will be aware of the cost of their calls. So these are three things where we had to think about the expectations and about how we manage something in the present and what will work in the future as well. But eventually we did this, not in 2 months, but let's come back to this later. And after this, when we had this situation, so we had the original application, we had the new application, and the two applications were using completely different tables in the same database, then we could do really the split, and we could move it to the Amazon cloud. And this was something that we knew that was very risky. We planned to do it in 2 weeks. And we knew it was very risky, and because of that we prepared a lot for that. We had a very detailed plan. We even assigned people for the plan. We knew that we will need half an hour for the move about. So we decided to come into the office on Saturday morning at 8 a.m. because we knew that this is the period when you have the lowest traffic. We had a bunch of people there. We knew the expectation and constraints properly. And we even had fallback plans, how we will roll back if something bad happens. We even had rehearsals before in advance. So because availability was very important, and we knew that we are talking about a lot of data, and we could stop the application, migrate everything, and then just start again, but we didn't want to do that. We wanted to do it with zero downtime. And so what we did, we created this new application on the Amazon cloud, and install the code there, which wasn't that big deal. We had to fix some things, but it wasn't that big deal. But what was interesting is how we moved the data, because we are talking about 40 gigabytes of data, but we wanted to move to the Amazon cloud in a production environment without downtime. So actually we decided to go with the Galera cluster in the Amazon cloud. Galera is the cluster solution of Percona. The other name is the XRDB cluster. And we set up a master application between the master node in the local data center and in one of the nodes in the cluster. And this is great because as far as you write to the data center or write to the Amazon cloud cluster, you can make sure that this setup will make sure that the data is always synchronized. So you will have the proper data every time, everywhere. And this is pretty stable as well, as far as you don't write to both sides of the replication in the same time, because this is async communication. If you write to the both parts in the same time, it may happen that the write commands will collide. And if they collide, then MySQL will stop the replication. And from that point on, you have a split brain. And you have to decide which kind of data you go with. or to rephrase it differently, you have to decide which data loss you go with. And because of this, we knew that this is something important, so we decided to implement a read-only mode in this user service. So it was used by the other service. We turned this read-only mode in. We rerouted the traffic to the Amazon cloud, and when we saw that everything is fine, we turned it on. So during these few minutes, people couldn't register and couldn't change their passwords. But that was how we could minimize the risk with this. We could have even fallback if we realized that the cluster is not working. And the interesting part here is just a side note that we prepared a lot, and we did 2 moves, and every time we had very interesting, very freaky situations we had to solve, no matter how much we prepared for that. But the important part was that we always had a plan B, and we always knew how we can fall back, so it wasn't that frightening. So if we look at this in retrospect, so the first thing, creating the new service, we wanted to finish it in 1 month. We eventually needed more than 2 months for that. We wanted to finish the rewrite stuff in 2 months. We needed about 6 months for that. And even for moving something with the preparation, with handling the data and with everything, it wasn't 2 weeks, it was about a month altogether. So if we come back to the original question, how long did it take, or why does it take so long? Then I can say that with introducing the microservices approach, we realized that we introduced a lot of new kind of problems, a new kind of failures what a system can have. We had to deal with, and because of the expectations, we knew that we want to do it with 0 downtime. We didn't want to risk too much in this. This is why we needed we had to be so careful. This is why it needed so much time. But eventually, what we have now is a system that has better ownership, better availability, and even better scalability. So looking back, even with this 10 months of work, it was absolutely worth it. Thank you very much.
Hi. So I have 14 questions.
Okay.
I see that you chose RPC, and I think, if I understood correctly, that the main reason why you chose RPC is because you wanted to rewrite less code, right? Because you wanted to, let's call it the front code, you wanted to keep those methods, but you just wanted the logic behind those methods to change to actually call the different services instead of ORM or something. But I was just wondering, so let's say that the alternative to this is to use REST and to have to rewrite actually more code. Like, if you had to decide again, like, would you choose RPC again? Because sometimes I have this feeling that when people need to refactor, they choose the solution that will mean, the least amount of code to rewrite. But sometimes I feel like if you rewrite more code, but create a solution which is easier to comprehend, you will actually end up saving time, even if you have to rewrite more tests. So I was just wondering, would you choose RPC again, or?
Okay, thank you for the question. Yeah, so the RPC is a more generic concept here. So if you talk about even REST, eventually it will be an HTTP call, and if you do a REST call from your code, it will be just a function which will do an HTTP call, which will do something and give some result back. So I think REST is more about the idea of how you design your API, but eventually it will be an RPC as well, because eventually it will do an HTTP request with a JSON response. So the technology behind that will be very similar. So and we chose Thrift here, which is if we talk about RPC and REST, we usually have the Thrift approach and REST approach, and that's an interesting question because we just try to move away from REST from Thrift to have a JSON API, but I don't like to mention REST because REST is not the technology in this case. The REST is how an owner of a service designs their API. So they can use REST if they want to, but it's not. But eventually the code will be very similar. So I think if we had to had to think about how much code we rewrite. It was more about, do we want to do the communication, keep the communication between the two services, or somehow we push the communication down to the client, which has a lot of benefits. But this is when we realized that we won't be able to rewrite everything. So what we wanted to reach with this project is to rewrite this code and in the same time show different approaches to future services, how they can solve this situation. This is why we don't support this expression with the foreign keys. I don't know if this answered your question.
Yeah, thank you. So now I have 13 more questions.
Okay.
Right. So thank you for doing this talk. I'm currently consulting for a company in Atlanta, and we're doing completely the same thing with Django and everything. So
cool.
Some differences, we migrated to Solar because it fits better, and we have a RESTful API for the microservices. And the thing that went wrong. And one more information: we have about 1 million of Django code, million lines of Django code. And one thing that went wrong is we didn't plan that well for the DevOps because you have double infrastructure. We had internal data center and then the Amazon. So now they have to deal with 2 different infrastructure, completely different tools and everything. And how did you plan for that? Did you increase your DevOps team? How much? Yeah.
Yeah. So we couldn't get rid of the physical hardware yet, I have to admit. So we still have this double infrastructure. But in our case, so we already had some experience with EC2. So we already had some different kind of solutions in EC2. So we had the infrastructure already for that. So in this project, we didn't have to write all the chef recipes for the EC2 machines because we had already some experience with that. And basically, so there is no such thing like DevOps team in our company. So the developers did the same thing. And yeah, there was some difference in the tools, but they are not that different in the sense that we are running the very same Linux distribution on both of these systems. And here we need VPN, there we don't need VPN and stuff like that. But it wasn't a big deal for us. So it wasn't a big problem for the people to get used to the new system.
Thanks for the talk. You said, if I understood correctly, that the microservices are owned by separate teams. Avishai just talked about having silos leads to excessive handoffs. Do you have any experience there? How does the collaboration between the teams work when microservices have to communicate?
Yeah, that's a very good question because we are just on our way to this really new approach. So we already have about 40 services, but not everything is split up. What we can see now that, so this part didn't change that much because earlier people had to communicate to each other. There was a function, there was a method or a class written by someone, and if someone didn't understand them, they had to go to the other person and talk to them. And we even had some ownership inside the code. The problem was that it wasn't that clear. So now what we have is just a much clearer ownership and a much clearer responsibility. So the people still have to talk to each other, and this is why we also have to keep in mind that the culture has to support this kind of infrastructure as well.
I have a question. So you migrated from a single MySQL instance to Galera cluster, right?
Yeah, it was a master application originally.
Yeah.
But yeah.
Okay. So how did you overcome the limitations of Galera, such as unable to use query cache on all nodes and the foreign key problem? So you actually can't use it if you have a synchronous replication with Galera.
So we weren't using query cache even with the original setup, so it wasn't that big problem for us. So what we knew that Galera cluster will be a bit slower since they will have to communicate to each other. But we always thought about that this is still much faster than what latency we introduced with the communication between the services. So we didn't really had to cope with that. And we use MySQL really just for storing the data. So we don't really use any special things like, we don't even use the foreign keys here because Django takes care about that, and we know that we even may have to split up this database to do different other databases in the future. So this is why switching to Galera wasn't that big problem.
Okay, and just another quick question. So regarding Galera, so if you already know the synchronous, I hope you're aware that each EC2 instance is actually a little bit different regarding speed, access, and everything else. You could easily come into some lag problems within the members of the cluster if you use heavy writes or heavy reads.
Yes, this is why we use only one node for writing. So in theory, Galera can solve the situation when two commits collide, and one of them will just roll back. So this is not that convenient as how it can be solved in one single MySQL machine. But this is why we don't use that, and this is why we only write to one node in one time from all the EC2 machines.
Hi. How do you deploy your microservices? I imagine that each of your microservice lives on multiple nodes. So are you using Chef or Puppet? And also, how do you manage security patches?
So what we do that we use Chef, but not for deployment, just for giving the baseline for the services. And there is a separate tool we developed for ourselves. We call it mission control and placement. What we use for deploying, and what we do basically that we upload the binary what we want to deploy to an S3 bucket, and all the nodes who has to deploy that new version get a notification and download this new version and deploy it manually on their own, or manually so automatically on their own node.
Hi, nice talk. I really liked it. I'm just wondering how isolated are these services among each other. You mentioned that each team is responsible for a service, but for example, if you have a user service or some kind of authentication service that returns a user object or something like that, and other services depend on this user object, for example, do they share code and stuff that works on this object, or is each service responsible for writing their own code?
Yeah, thank you. This is a very good question, because at first when we began to think about this whole setup, we were thinking that there will be a service owner, and we as service owners will provide client libraries for the others. And from that point on, we can say that we can even put code into the client library if it's needed, so the people will be able to use that, and this way they sort of share code, but basically the ownership so that code belonged to the service owner, but the service was run by the other service owner, so the code was run by the other service owner. So we realized that this is not a good solution. So what we do now is we put more and more code and more logic to the server side, to the original service side, and give just a very thin library for the other services to use it. So we are moving to a setup where they won't share any code at all.
So most companies, they reach the microservices architecture as a way to scale the company in terms of employees, of workers and engineers. Because as engineers, the number of communications that you have to keep, it rises in the order of n squared. Like everybody has to communicate with everybody else. And microservices is this way of chopping down the communications, the communication channels to basically the API calls. Like now I only have to keep one channel for every service that I'm using this API, more or less. So this tends to change the way the company acts. Like if you have microservices now, then people talk mainly within the service group or the service department or however you call it, service team, and not as much between teams. So how do you solve this problem? How do you deal with this problem? How is this affecting your company now?
So at first, I don't really think that the microservice is the only way for that. So with strict rules, we can introduce strict interfaces. But oh, is it? Oh, thank you. So you can introduce strict interfaces, and even in one code, people can communicate to each other through that interfaces. So there are solutions for this, even not only with the microservices approach. But yes, it makes a lot of things clearer, and what changed with this is basically just what people could expect from each other. So the teams are still communicating to each other, but what we can see that if we have this API, it's easy to create a documentation for that, it's easier to have an SLA for that, and people can just expect things from each other. And so we didn't have to change the culture in this way, just people could be more relaxed that they can rely on this other service because they know that their test won't break because of the other party's code. I don't know if this answers your question.
More or less, yeah.
Okay. Thank you.
Thanks.